These are the solutions to Year 14 A22, which is Physics 5, and this is my Unit 1, capacitors, and these are the answers to Homework 1. So number 1, Part A, Part 1, define the capacitance of a capacitor. So capacitance is ability of a capacitor to store charge. I'll just scan out a wee bit so you can see all of that. Part 2, define the farad, the unit of capacitance. So if we just write down the equation, we know that capacitance is charge over voltage. So if we were to replace that with 1 farad equals 1 coulomb over 1 volt, then we're defining 1 farad is the capacitance of a capacitor which can store 1 coulomb of charge per unit volt. So 1 farad is the capacitance, and of course it's only a capacitor which has capacitance. It's the capacitance of a capacitor which stores 1 coulomb of charge per unit volt. I'll just move that over a wee bit so you can see it. B, Part 1, the diagram below shows an arrangement of 6 identical capacitors. Each capacitor has a capacitance of 22 microfarads. I'll just go out a wee bit so you can see the whole thing. The maximum safe potential difference across a single capacitor is 50 volts. Find the total capacitance of the network between the terminals X and Y. So we'll just go in again there. So there's X and Y. Each of them is 22 microfarads. Now, if you remember that capacitance, when you're adding up capacitors in series, it's the opposite to what you do with resistors in series. So with resistors in series, you just add them. With capacitors in series, you have to do 1 over plus 1 over, or you can do product over the sum. Or if you remember, if you have 2 identical resistors in series, in parallel with each other, the total resistance is half of one of them. This works exactly the same with 2 identical capacitors in series with each other. So the total capacitance of that line there is half of 22. So each line then is equivalent to 11. If I just write beside them, each line's 11. And since there are 3 lines, and those 3 lines are in parallel, for capacitors you just add the 3 lines in parallel. So the answer is 11 plus 11 plus 11, and that's 33 microfarads. You could, of course, also, for this one here, you could do 22 over 22. You could do the product of the sum, which is 22 times 22, so we'll just check that. It's 484, and then the sum is going to be 44. We're hoping for an answer of 11. And the answer is 11. So each line is 11 microfarads there. I'll just show you that sum there. 484 over 44 is 11. So that's a product, 22 by 22 over 22 plus 22. So that's your answer to that. I'll just go out again to show you the next question. It says find the maximum safe potential difference that can be supplied between X and Y. There's X and Y again. You're told the maximum safe potential difference across a single capacitor is 50 volts. I'm going to write that in a different colour. So one of these is 50 volts, and that means that every single one is 50 volts. But if you remember that across each line in parallel, your total voltage across each line is exactly the same. So in total you can have 100 volts across each line. So the answer there is 100. 100 volts is the answer to that. So that's the end of page 1. If we have a wee look now at page 2, a capacitor of capacitance 22 microfarads is charged by a battery of EMF 9 volts and negligible internal resistance is shown below. Calculate the charge in the capacitor. So all we're going to do is use the equation C is equal to Q over V. When you rearrange that, you get Q is equal to C times V. And that's just 22 by 10 to the minus 6 multiplied by 9. And that gives you 198 by 10 to the minus 6. And it's just simplest to leave that as micro. So it's 198 microcoulombs there if you put the micro in. Now the next question is a very common question. It tells you that your 22 microfarad capacitor, which had been charged to 198 microcoulombs, is now disconnected from its battery, and it's then connected to initially uncharged capacitor. Now sometimes I suppose it's hard to decide whether that's in series or parallel, but you can see that's definitely joined there, and if you were to take two connections out the side, that's definitely a parallel circuit there. Sometimes it would also maybe say, it's showing you the diagram here and you can see it's in parallel, but you can also maybe say, sometimes it maybe says something about across, it's joined across another second capacitor. If you weren't sure whether it's a series or parallel, a series circuit of course should look, I'll just draw this over here, something like that, and those two lines should be connected then to the rest of the circuit or whatever. So you can see that's definitely a parallel part of the circuit. So after this reconnection, what happens? Well, the 22 microfarad capacitor was charged to 198 microcoulombs, and it then shares its charge until it kind of equalises the whole system here. It shares its charge with Z there. So its charge is going to go down, and that means the potential difference across it is also going to fall as well, because there's going to be this equaling out of charge or whatever. So if you have to calculate the charge now, you now know that it's fallen to 2.9 volts. I'm going to put that in there, over there. And you're told that the PD across 22 microfarad has fallen to that. So you're just using your equation again. So C is equal to Q over V. And we're looking for Q, which is equal to C times V. And that is going to be equal to 22, I'll just write the micro in there, by 2.9. And that gives you an answer of 63.8. And that's microcoulombs. What is the PD then across Z? So if you remember a minute ago, we said that 22 microfarad, its voltage had dropped to 2.9. And in a parallel circuit, whatever you have across one capacitor, you have across the other. So the answer there for Z is also 2.9 volts there. The answer is also 2.9 volts. It then says calculate the capacitance of capacitor Z. Now, you do know its voltage. The voltage across it is 2.9 volts. You know that the 22 microfarad capacitor shared its charge, and we now know what its charge was. So initially, the charge on the 22 microfarad capacitor was 198 microcoulombs, and that was the answer to part C, part 1. And it has now dropped to 63.8. So it must have given the rest to the capacitor Z. So when you take those two numbers away from each other, you end up with an answer of 134.2, and that's going to be the charge across Z. I'll just write a wee Z here. So the charge across Z. So we know if its voltage, we have its charge. So C is going to be equal to Q over V, and that's equal to 134.2, and it's divided by 2.9. And the answer comes out as 46.3, and again it's micro, 46.3 microfarads.